So let's look at some solutions to some of the sample questions in a simple pendulum, so that I just show you how you can apply the formulas that we looked at. So these are questions that came in some of the ECZ past papers. So it says question number 1, the diagram shows a simple pendulum that swings from A to C and back to B in 0.75 seconds. So they're telling us it swings from A to C, then it comes back to B in 0.75 seconds. So remember, each time that you are dealing with your physics, your science, it's always good to list down the information that you have been given, which we call the data here. So they have given us the time it takes to move from A to C and back to B, which is 0.75 seconds. And remember, what did we say? How many oscillations in this case? So sorry, this is the time they have given us, but we can identify the number of oscillations from A to C and back to B. It's like you have made 1, 2, 3 moves, so it's 3 over 4 oscillations. That's what we mean. But like I said, if you're not so comfortable using a decimal, you can say 3 divided by 4. That will give you 0.75. That's what it simply means. Then the question says calculate the period of oscillation. So A is asking us to find the period. Remember, since we are looking for period that we don't know, period is equal to time divided by the number of oscillations. So time is equal to period is equal to, what's my time? It is simply 0.75 seconds divided by the number of oscillation. If you are not comfortable, you can use it's 3 over 4. If you are not so comfortable, you can change that to a decimal number, which is 0.75. Of course, if you are to put that on your calculator, 0.75 divided by 3, let me say divided by 3 over, sorry, 0.75 divided by, 3 over 4, 3 over 4 there, it is going to give me just the 1. So if I want, I can say it is 1.0 seconds. So that's the period that they wanted us to calculate there. So you can see there's nothing complicated, it is very simple. Then the B part there says the frequency. Now what we can do is that, since we know that frequency is equal to the number of oscillation divided by time, if I want, what I can simply do, the number of oscillations, let me take that one in decimal point, 0.75 divided by my time, which is 0.75. You can notice that this is still going to give you just the 1 Hz. And it is true, because we did say, alternatively, you could have said frequency. You could have said that, frequency is equal to 1 divided by period. Because your period is 1, so it would have been 1 divided by 1, which will still give you a 1 Hz there. So you are able to see there. Okay, let me slightly just change the values now. Let me slightly just change the values so that I can still demonstrate to you another question on the same. Let's say that instead of the time there, let's put it in this case as 2.05 seconds to move from A to C and back to that. This is another question that came in the ECZ exam. So if you look at the data there now, I've now changed. I'll call this one as being question number 2. So the time taken to move from A to C and back to that, the time is simply 2.05 seconds. And the number of oscillation in this case is simply 3 over 4. That has not changed. If you want, if you divide that, 0.7, 5 oscillation. So the first question there says calculate the period of oscillation. Period, as usual, it's the time over the number of oscillations. So period will be equal to the time, 2.05 seconds, divided by the number of oscillations, 0.75. Therefore, the period is going to give me, if you try to do that, 2.05 divided by 0.75 divided by 0.75. That is going to, okay, so 2.05 divided by 0.75, that is going to give me 3.333 That's what, sorry, I've not typed properly. 2.05 divided by 0.75. All right, so that is going to give me 2.7 to 2 decimal places. So that would be 2.73, and this is going to be in seconds. So that's what I wanted you to do there. Right, for the B part, it says we calculate the frequency. So we know that frequency is equal to the number of oscillation divided by time. The number of oscillation in decimal, it is 0.75 divided by the time, which is 2.05. So if you work out that, if you were to work out that 0.75 divided by 2.05, what is that going to give you? So it is simply going to give us there 0.3 to 2 decimal places. You round off, so that is going to be 0.37, and remember the unit for that is simply as. Alternatively, a person would have also done this to find the frequency. Frequency is equal to 1 divided by period, because we know what the period is. So I would have said frequency would have been 1 divided by period. You replace with that 2.73. So what is that going to give you? So it's 1 divided by 2.73. 2.73, it is still giving me a 0.37 Hz. So you can see the solution is simply just going to be one and the same thing. That is what we mean there. So you don't need to worry, it is simply going to be just the same. All right, so on the same diagram, sorry, I'm just trying to use the same diagram, but I'll try to make alterations. I'll make it as question number 3. Let me say the diagram shows a simple pendulum that swings from A to B. So this time I'll just say from A to B. So let's say from A to B in 0.64 seconds. All right, and the question says calculate the period of oscillation, then the frequency of oscillation. So now I'm just talking about moving from A to B. So it moves from A to B, but in what time from A to B? 0.64 seconds. So meaning, according to the data that we have there, the time taken is simply 0.64 seconds. And what's the number of oscillations